All right, I think we will get started with some introductions, or at least introductory slides, moving into today's webinar. Um, I am Jim Sweeney, Director of Product Management for Synaptica, and I'll be introducing the webinar today, Knowledge Modeling for the Task at Hand. Again, thanks all for joining, and I am seeing a few familiar names, not faces, of course, but we are appreciative that you join us today. So let's go ahead and move through. And again, we'll then move into the webinar and have a live QA session following that. Okay, so just a little bit about what we will be presenting, or the format. Again, we'll just do a quick introduction, a few minutes here. The presentation goes about 20 minutes, and then following that, we will kind of open the floor to a QA session, and we'll get to as many of those as possible live during that period. And then down at the bottom, you'll see any others that we're unable to get to. We'll certainly follow up individually to get an answer back to you. As noted, the webinar is being recorded, and yes, it will be, I just saw a question pop up, will be provided, a link to that, probably on YouTube, will be provided by email to all participants soon after. And as noted, it looks like people are using the chat. There should be a QA option in your interface as well, and that's where we can go ahead and specifically address questions. So that's what we'll want to use to get back to you on any questions as we move through the presentation and following in the QA period. Just a little bit about Synaptica. We've been around for quite a while, 25 years in the industry. We've gone through a few different iterations over the years, and really started kind of as what's described as kind of a service bureau, meaning that we were initially, I shouldn't say we, this goes back quite a ways, but developing taxonomies and other types of controlled vocabularies. And given that this was the era when this was taking place, there really wasn't purpose-built software for that. So Synapse was the name of the company at the time, took it upon themselves to develop that, and have been licensing it pretty much ever since, specifically our initial product called KMS for Knowledge Management System. One of the keys that we focus on is really adhering to standards and best practices as they evolve. Certainly that continues to evolve over time, and we see additional kind of RDF, W3C, linked data standards. We try and take advantage of all those and any of the latest technologies, graph databases and things like that as we develop our new products and look towards the future. We really have developed our tools from the point of view of the people working in enterprises and organizations doing the work themselves. So rather than an IT kind of point of view, obviously we've focused on knowledge workers, library and information scientists, taxonomists, ontologists. Oops, there's a little typo there. Building tools that will effectively do what they need to do and present an interface that is intuitive and easy to use for the tasks that they're focusing on. And in general, we really have made it a policy to work with our customers to make sure that what we're offering is going to meet those requirements. And I mentioned before, not only current requirements, but also really hope to kind of be future-proof and make sure that we're designing to meet needs as we go forward. And then, just to reinforce, really our mission is and has been to help our customers organize, categorize, and discover enterprise knowledge and information. That's really taking advantage of what may be decades of work and information and making sure that it's available, discoverable, and really can be employed to benefit the work within those enterprises. A little bit about this webinar and those to come. We will be producing several other webinars going forward over the next several months. looking at a number of different things that really across the knowledge management kind of space, practices, principles, a little bit about standards and how we employ them, you know, within our tools, or just generally how they're developing and evolving over time. Today, specifically, we'll be looking at different modeling methods, talk a little bit about what those mean and what they are, as well as some designs and how those are best applied in kind of practical day-to-day situations, when it makes sense to use one versus another, and so forth. And then, of course, looking toward the future, and in our following webinars, we'll kind of go more into depth, hands-on kind of practical information about how to build those, everything from simple kind of term sets and flat files that we can centralize and standardize across an entire organization or enterprise, and then talk about how we can employ those as well to kind of construct ontologies and knowledge graphs going forward. The presenters today will be Ahren Lehnert and Bob Kasenchak. Both have been in the industry for a number of years. Ahren is the senior manager for the development of Graphite, which is our newer taxonomy and ontology management tool, as well as doing work within text analytics. Bob Kasenchak has worked as a taxonomist ontologist for a number of years, helping to really put together those vocabularies, as well as how those can be employed for indexing and text analytics. So with that, we're going to go ahead and jump into the webinar itself. And again, we'll take questions following that. Thank you.
Welcome to our webinar. In this webinar, we will cover types of knowledge organization systems, which we call a KOS. We're going to talk about use cases requiring a KOS. We're going to discuss determining which type of KOS best fits each of these use cases. And we're going to talk about some examples of KOS in practice for each use case.
Knowledge organization systems come in a variety of types. This table presents some of the most common in descending order of complexity. At the top are controlled lists, which are usually flat, non-hierarchical lists of controlled values, such as a list of countries, or a short topical list, or information that you use in pick lists. Going down the list, knowledge organization systems get more structurally complex, adding hierarchy in the case of taxonomies and thesauri, and other data attributes. And finally, the most complex knowledge organization systems are ontologies, which are formal vocabularies that can be ingested by multiple systems. Note that this is not an exhaustive list of vocabularies, but it represents the types we work with most often in our use cases.
We usually see the spectrum of knowledge models presented along a line from the least to the most complex. Here, we're trying to represent additional dimensions of complexity and overlap between the knowledge models as well as overlapping use cases. Each knowledge model gets more complex, but they are overlapping. There's a progressive evolution from simple lists to hierarchical structures with relationships to ontologies with additional features such as classes and axiomatic reasoning. As we move up from the bottom left to the top right, the spectrum of applications becomes narrower and more complex. However, the complexity is a gradual building on top of knowledge organization structures which may already exist. In this way, an organization can start out with simple lists or shallow hierarchies and build in complexity and more advanced use cases over time and as each new project comes along. This natural progression allows for an advancement into more involved knowledge organization structures interacting with each other and externally integrated systems. As we go through this presentation, we'll see each type illustrated, and then we'll talk a little bit more about each use case. For now, we're going to go to the next slide and see the various dimensions and explanation. So on our x-axis of that cube, the knowledge model complexity is represents the complexity of each knowledge organization system model. The y-axis is about the complexity of the data and the content in that use case. And the z-axis is really about the level of effort, representing the effort required to develop maintain, and govern the models, the tools, hoarding the models, and the overall information architecture of which the model and the vocabulary management tool are a part. All of these things work in harmony, and as the systems get more complex, so too typically does the model.
There are many reasons to carefully consider modeling options. Complex systems require more effort to build and governance to maintain and may not be necessary for simpler tasks. However, complex systems can be powerful tools which are extensible and you will find other applications for in your enterprise. Some models lend themselves more easily to extension, and some projects will require a variety of systems, models, and integrations to complete all the needs for a task. And as mentioned, some models require more extensive governance and maintenance than others. It's relatively easy to maintain a flat authority file of a list of country names. It's more complex to govern and maintain a thesaurus, and even more complex to govern and maintain an ontology. So the idea is to understand the requirements of your project and the various options you have, and select the right information model for the job that you have at hand. So we're going to briefly go through some examples of projects and talk about requirements from a number of perspectives and discuss which models are appropriate and why. Navigation for websites is often a good use case for taxonomies, usually fairly small and shallow taxonomies for purposes of display. Semantic relationships established in navigation taxonomies are often not strict, as these vocabulary structures are not used to model a topic, but rather to quickly allow people to find an appropriate page or resource on a website. For these reasons, a dedicated taxonomy tool may not be required for this kind of task, although navigation taxonomy might be mapped to a more complex topical taxonomy. More about this later. Since websites do change, some governance is required, but compared to other more complex taxonomies, it is usually relatively low effort. Some design considerations must be considered for display space. Usually you have limited amount of space to have a list of topics across the top or navigate on a website. This example on the next slide is from Synaptica's website. You can see across the top there are 6 terms for basic navigation across the top of the page, each of which pulls down into a submenu, and a few even have subtopics. So overall there are only about 20 terms, and this lets visitors to the website quickly navigate and find the resources that they need. This is not a semantic model of how these topics interrelate. It is merely a navigation model. It is fairly shallow, only about 3 levels, and only has 6 top terms. Our next example of a project is classifying content. For example, selecting tags to apply within a CMS or digital asset management application is often achieved using a set of independent or interlinked pick lists or small taxonomy structures. This often includes topics as well as metadata like audience type, content type, and other kinds of similar values. These values can and will change, so depending on the size and complexity of vocabularies, an external taxonomy system, besides whatever is native to your CMS or DAM, may or may not be required. For example, a topical taxonomy could be quite large, while other pick list type values are usually relatively compact. Tagging content with metadata can be done by hand or automatically, in which case text analytics or auto classification software might be included in your stack. On our next slide, we see an example of a Confluence page being tagged and classified with metadata from Graphite, our taxonomy and ontology management tool. There are several fields that require data. Each field pops open a small list or a small hierarchy of terms that can be applied to that field to classify a specific piece of content.
Our next use case is about search and retrieval. And search and retrieval usually includes searching for content and data within one or across many repositories. Here, we're talking about faceted taxonomies and thesauri for use. And this gets into more of a medium data complexity, a little bit more complexity in the knowledge organization system, a little more effort to get going. But once used, you can use faceted taxonomies or thesauri, and the facets allow for crossing the different dimensions to filter content. And an example of this might be performing a keyword search and then filtering by facets such as document type, organization, people, geography, et cetera, et cetera. The benefits include improving the findability of information and leveraging semantic relationships for tasks like content recommendation, related documents or people in the organization, or working towards more complex ontologies to surface content. In this scenario, a search tool is typically the front-end search within a content management system, or it can be, with a vocabulary management system providing controlled terms on the back end for tagging, using search facets and then injecting metadata into the search index. Optionally, automatic categorization tools can also be thrown in the mix to classify content before it's searched and apply those tags. So we have an example here in which we see a search interface in which both free text keywords and structured faceted parameters from a taxonomy can be used to predefine and pre-coordinate and structure a search so that you are using both free text values that you might type in as an individual and controlled values that come from something like a taxonomy or a thesaurus. Our next use case is very similar. It's about product and retail, and you can see here that the cube is, we're picking the same types of taxonomies and thesauri. So in this instance, an e-commerce search for products on retail websites, they also leverage these faceted taxonomies and thesauri. The front end might be a web content management system, allowing for search and navigation. The assets on the site are tagged, in this example, in digital asset management systems, and this metadata is part of taxonomies or thesauri, which present faceted filters much like a search and retrieval, but also include product information from perhaps a product information management system for things like color, dimensions, and other specifications about the product itself. Some of the benefits here is similar to the search and retrieval that might happen on an intranet, but this is on the front end, and so this could be a customer-facing e-commerce site allowing users to combine navigation with search to find specific products, and can allow for product recommendations too. So here's an example from a big box retailer in which we're using a combination of navigation and search. We've drilled down using navigation from appliances to refrigerators to French door refrigerators. They've given us a landing page, and they're kind of also giving some popular filters. If I were to dig into this, I might get some recommendations of things I might like based on as I'm browsing. But you can see here on the left too that we've got filters, and these are really faceted filters. And again, some of it may come from taxonomies in a taxonomy management system. Others may come from product information management catalogs where it's more data and specifications about the product. So we've got appliance, color, finish, we've got the number of doors. But if we're talking height, width, length, those kinds of things, they can be also integrated into that and brought forth to use for filtering. AI and machine learning. Machine learning, you'll see there's a real discrepancy here between coordinated lists, which are quite simple, and ontologies, which are quite complex. And the reason that we have both indicated here is that coordinated lists can be used for tagging assets for training machine learning models. And then once that model is trained on this more simplistic use of coordinated lists to tag information, the machine learning algorithms can then tag content automatically and can perform other functions like adding to an existing ontology by pulling out entities and facts from unstructured and structured content. Now here, the data complexity and the KOS complexity is quite high, as is the level of effort, because you are really dealing with machine learning models, and you're going to have data scientists working on that kind of information. But here, in this example, we see that we can use simple lists that can be used for tagging images, which are then learned in supervised machine learning models for later tagging of new content. The potential extraction of new features and content to add to an ontology is also there, which can be used in knowledge graphs. And some of the benefits, it allows for the consistent tagging of this training content and connecting these disparate data sources. Likewise, it can help with the mapping of existing ontologies or the identification of new ontologies, allowing for analytics and reasoning. So in this screenshot, we have what appears to be a fairly simple tagger. They're using very simple flat lists. You can see over here we've got stop sign, chimney, kind of basic kinds of entities, cars and trees. And this can be used to tag this training data, this image, which is then fed into the machine learning models. And then they can begin to automatically tag images in the future and combine multiple data sources and concepts into mapped ontologies to be used in something like knowledge graphs, which we'll cover next.
Our final example of a use case is about knowledge graphs. Knowledge graphs can combine the features of many of the other use cases discussed. Ontology-based knowledge organization systems are complex in terms of effort, systems, and integration to model and deploy, and require more complex and time-consuming governance processes than many of the other structures that we've discussed already. Knowledge graphs begin with ontologies, which are then connected to content or data to provide enhanced search experiences, power chatbots, derive machine learning data sets, and other uses. Certain sections of the ontology, usually a topical taxonomy and perhaps other terms, are connected to data or content to create powerful and useful applications for end users for analytics, enhanced search results, and other uses. Once established, knowledge graphs have many useful applications beyond search, including reporting and machine learning data sets, as Ahren just discussed. So knowledge graphs based on ontologies are powerful tools which can be extended to many other use cases once they're in place. The paradigm for knowledge graphs and the way most people have been introduced to knowledge graphs is still the Google Knowledge Graph. The genius of the Google Knowledge Graph, of course, is that you don't have to do anything to interact with it. You just use Google as you normally would, and on the screen you see here, which is a Google search for James Bond, on the left side of the screen you get traditional Google results, a list of websites that match your search. The card on the right-hand side is a knowledge graph that takes the concept that was in the search, and instead of providing search results of websites that match it, it provides other information about it. In this case, photographs, a link to a Wikipedia article, a filmography, and other information that it takes from other linked data sources to combine into an integrated and rich search experience that combines traditional search results with other information about the topic that's being searched.
So as we've discussed these different types of models and use cases, we've talked about simplicity and complexity, and this may seem very daunting or intimidating to increase the levels of complexity in your knowledge organization system. But it is really possible to start simple and to make incremental changes to knowledge organization models and these basic systems to get to more complex systems. There are benefits at each level. So you can really evolve from simpler to complex models, and you can combine simple and complex models within a complete information and knowledge management system. And what we're illustrating in this image here is on the far left, what we have is literally a screenshot of Excel. And let's be honest, most of us who work in taxonomy or any kind of control vocabularies, that's typically where we start. We start in spreadsheets, whether it's Google Sheets or whether it's Excel, but some kind of spreadsheet. And this could be a flat list or a hierarchy. And then we get beyond what Excel can do. It can only do so much. And we want to manage our taxonomy in a dedicated taxonomy management system. And this could be something like a list, which we have in our next column here of films. It's a flat list. There may or may not be any other relationships to it. It's pretty simple. And then we move up, as we've shown before, and we're looking at taxonomies and thesauri, and then we're moving into ontologies. And for many organizations, this is not an overnight transition. And some stay with lists, and others evolve to more complex systems like ontologies and getting into knowledge graphs. Some start off with ontologies and knowledge graphs. But this idea of building on the thing you had before makes this less challenging and less intimidating. To really start with the basics and things you probably already have in your organization, and then to start to build on that and build the complexity as it's needed for each of your projects as they come along.
So to sum up, the complexity of a knowledge organization project is determined by multiple factors: the data, the knowledge organization system in use, and the level of effort needed to maintain, govern, stand up, and possibly integrate systems in order to accomplish a project. Projects can evolve over time and become more complex and adopt more complex systems as they are extended to meet additional business use cases and other project needs. And the main point is that the complexity of the use case can help determine the level of complexity of the model that you need to get started. And despite the data and knowledge organization system complexity, there are processes and tools to help build, manage, and deploy vocabularies for use in knowledge organization projects. Thanks for joining us for our knowledge modeling webinar. If you would like to talk more about any of these topics, please get in touch with one of us using any of the information displayed here.